Hey, hello, and welcome to the show. It's me, JP, and it is time for JP's product pick of the week. Here we are, yet again, with some cool, exciting, interesting, mysterious product from the Adafruit store. And the first thing I'll do is let you know you can head right over to the product page in order to get a 50% off discount on that. So just point your camera at that or go to this URL, head on over there. It's going to look an awful lot like this right here when you head there. And what you're going to see there in red is the temporary 50% off price. So if you head to this URL right now, check it out. We're going to talk all about it. I'm going to show you a little Lady Ada video from the past. I'm going to grab one out of my own cabinet of mystery wonders over there, and then I'm going to do a couple of demos for you, show you some code. We'll have fun. And I think it's a good chance for you to go and grab a very cool product at a very cool price. So without further ado, let's have Lady Ada of the past introduce us to this week's product pick of the week. Take it away, Lady Ada.
We have...
It's because it's so itsy bitsy, it can hide it places.
I know. So this is a 2.13-inch e-ink display that's high resolution. We actually got this as a feathering last week. Now we have it as a breakout. It's really nice. It's high resolution. It's it's not going to be as high res as like a Kindle display, but for a low cost breakout board, you get quite a few pixels. It looks really good. It also updates a lot faster than
There's not live video, I don't believe it. Oh,
tricolor. So this is the live demo. So you see, you can update the whole display.
Super Kindle-like.
Yeah, it's really nice.
I think it's faster than my Kindle.
It's faster than like the first Kindle probably. It can do partial updates, but we haven't set that up yet. This is just it displaying an image from a bitmap, and this is running off of a Metro. And you might think, hey, a Metro doesn't have enough RAM to display 8K of bitmap data. You're right. It has an SRAM chip on the back that does all the frame buffer management for you, so you don't have to use any RAM. Because of these displays, you can't draw one pixel, you have to draw the entire display at once. So if you want to do any graphical stuff, you'll need to have a frame buffer, and our breakouts come with a frame buffer in them.
Okay.
So a nice ink display.
Hey, that does sound awful cool. In fact, I'm going to run over to my cabinet of mysteries and wonders and things and go grab one for myself. I'll be right back. Yes, that's right. This week's product pick of the week. Let me try that again. Yeah, that's right. This week's product pick of the week. Ooh. It is the 2.13-inch monochrome e-ink display Breakout with the SSD 1680 driver on it. So this is a e-ink display. Has basically one color, white or the black e-ink balls in there, or however it works these days, I forget. And this has a little row of breakout pins that you can solder some headers onto or wire directly, and then plug it into a breadboard, plug it into a permaproto board, build a circuit around it. I'll show you a couple of options. And then drive it from pretty much any microcontroller. It's got the horsepower as well as a SD card and some SRAM on there to handle the buffer so that you don't have to worry about that on your card, which is excellent. So let's get to it. First of all, you can see here, this is a really gorgeous display. It's nice and high resolution. What I'll do is actually switch over to down shooter here. There we go, that'll work. And you can see here I've got my logo on there. I just built that version of the logo this morning, and that is a essentially it's a BMP file. I think you can do, this is a 16-bit BMP file, even though it shouldn't be. It should only be a 1-bit, but the code I was using wanted this format, otherwise it was inverting it. So, what I'm going to do is actually show you, so someone asked, can you remove the power from it? When the MCU powers it on, it won't clear the screen. So let's see, in this case, if I power it down, so I'm just going to remove USB power from this little Metro here. You'll see, yeah, it's an e-ink display, which just wants to display what's on it the last time that we had something on there. My code doesn't do anything clever. It just says, hey, when I boot up, I'm gonna refresh the display and re-image it with whatever text or BMP was on there. So you're gonna see it's gonna do its little refresh. There, it kind of inverts the screen, does black, does white, and then it displays it. But you can see it's a really quick refresh. I'm sure in code you could come up with ways to not refresh it when you boot it, unless you need to put a different image on there than the one that was on there last. There's definitely ways you could do that. So what I want to do is actually show you on this one, I'll do a couple little refreshes and show you some code for this. So let me switch to a code view of the world. I'm going to jump over to my text editor. So I have this running in CircuitPython. You can also use Arduino for this, and you can run it as CircuitPython on the microcontroller, in this case this Metro. You can also do it from a computer using Blinka. So let's take a look at the code. How are we running this? We have a few imports for time, board for pin definitions, display I/O, and then this driver, the SSD 1680. We release the displays, set it up on its being used on SPI, as well as some clock and data pins, reset and busy. Then we set up the display bus to talk to this display at this baud rate, set up the display object itself. You can see here we have set up for the width and height. There are some optional things you can do in here. If this were a tri-color display, you can have a highlight color set up. As well as the rotation. So this is naturally a vertical display, but we're using it tilted 270. You can see here, in fact, if I change this to a 90 degree, we'll essentially flip it upside down. So I've just hit save, and you can see there it goes through its little refresh, and it's actually pretty darn quick. Let me flip it back. The next thing we do is set up the display I/O objects, so we have a display group. And then we are going to, in this case, import a file. So I just made a little convenient set of variables for myself to import whichever one I want. So file 1 is the Adafruit logo. So what I'm going to do is in this open loop, we open up that file. I'll switch that to be the Adafruit logo. And then we set this up as pick is display I/O on disk bitmap, and it's using that opened file. The tile grid is set up, and then we add that to the group, show the group, and refresh, which is what causes it to actually do the little refresh. And then I'm just holding it there with this while true pass. So if I save this right now, you see it's going to go through its little setup, and it's going to pop on there the Adafruit logo. By the way, you'll notice some little crumbs on there. That's because I dropped the board and it banged into something, and I now have some stuck pixels. Colin was just telling me there might be a way to fix that by flashing it with black and white for a few minutes, so I might try that later. So we'll do one more. So these are black and white logos that you saw. You can also do dithered logos, and we have some guides about how to do all of this. So what I'm going to do is change the file to open this picture of the David. And you'll see here this was a grayscale or color image that I converted into a dithered image. So you can see, even though this is only a black and white display, essentially, you can make it look like there's grayscale by using halftoning techniques or other dithering techniques. This is actually a diagonal halftone, which gives you a pretty nice look, almost like a woodcut type of look. So now something else we can do. What I'm going to do is actually pull this screen from here. And I'll go ahead and unplug that one. I don't need that now. And let's go to a full down shooter view. And how about like that? Okay, so what I have here is a cool little setup. I thought it was cool. I've set up an itsy bitsy M4 on this Perma Proto board and soldered all the connections that we need. And then I also soldered onto there a header row, a socket header row that's tilted at a roughly 45 degree angle, which means when I plug this into here, we get a nice little semi-vertical display. And what I wanted to do is actually set this up as sort of a page-a-day calendar. Really what I often want to know is today's day of the week and the month and the day. I usually remember the year, so it's not as important to me. I don't need a lot of fancy stuff. All I really need to know is what the heck day is today, and also the date can be important for me. So let me plug this in, and you'll see it's gonna actually. I'm gonna do a little setup. So check this out. First of all, I'm gonna run a little Python script, and I'll plug this in first. It needs to find that on USB. Hopefully it finds it. Hey, it did. Whoops. So now I'm going to reset the board, and you'll see, go back to this downshoot. You'll see it's now updated it with today's day and date, and that's grabbing it from my computer. So it's grabbing the computer system time, which is what that Python script does. And then I think right now I have it set up to wait an hour. And so every hour, both my Python script and the CircuitPython script running on this little microcontroller will go and check together. Essentially, the computer will check and see, hey, what's today's date, day and date, and then it's going to send that over serial on the USB over to the Itsy Bitsy M4. CircuitPython software there is waiting for input, and when it grabs that input, it then displays it up there. So now I have a nice, neat display that just tells me really the most important thing for me is what's the day, what's the date. You could do this with a clock, but of course, the update, the refresh, we're not really meant to update these more than once every 3 minutes, or you can diminish the display. You can cheat for sure, and I've done that before. I don't remember what command we have, but there's a way that we can get around that that delay that's normally being enforced, so you can update more quickly. Of course, you'd want that if you were doing something like a book reader. You'd probably update it quite frequently while you're reading and then not update it at all. So it balances out in the end. So let's have a look at the code for this. Let's, first of all, I'm going to jump over to this Atom view of the world. And I should say, who am I talking to? Well, you, the viewer, but also the people on Discord and the people in our YouTube chat. So I want to say hi to all of them. Hi, Aiden. Hey, Scotty. And we've got a lot of people over in the Discord. If you're wondering where that chat is happening, go to Discord. It's adafruit.it/discord, and that'll get you an invite, and then you can join in the live broadcast chat channel. Dexter Starboard asked, does it react to magnetic field? Not that I've ever seen. It's possible, but that would be actually a good question for Colin, and that could be a fun demo video. Can he build a magnet big enough to change the image on there? Todd says, slick wiring. Well, thank you. Let's see, any other questions? E-ink can sit weeks without power and still show your image, but a refresh now and then can keep it from discoloring over time. Oh, that's good to know. So let's take a look at this code here and what's going on. I'm going to switch over to two things. So first of all, this is the Python script. And big thank you to ToddBot, who has up on his tips and tricks page some stuff about talking over serial, and he helped me out with this code. So this is to talk from your computer using serial to your CircuitPython device. So in Python on my computer, I import serial, I import time, I find the serial port, which I don't have anything clever doing this, I just checked what it was and hard-coded it in there. And then we create the serial port object, and we do a little reality check by doing print of sir.name. And then in the main loop here, we grab the date and time from the computer using this date string equals time, string f time, and then I'm sorting out just the stuff I want. So I'm getting the day, and then I'm putting a sort of escape character here with this slash so I can split it later. The month in capital, both of those are in capital, and then the day of the month. And then we have a return and a carriage return, end line and carriage return. We print this out again for a reality check. That's what's happening over in the Python. You can see it there when it was running. Let's see, yeah, you can see there it says sending date string Tuesday / July 06. So then I write that to the serial port. That heads over the serial port over to the CircuitPython device that's waiting. And then I spend an hour sleeping there, close the serial port. So if we look at what's happening on the device itself, on this Itsy Bitsy, I'm importing time, importing the board for pin definitions, display I/O, the SSD 1680 display driver, bitmap font, and display text, so I can use a fancy font. And then we release the displays, we set up the font, I have two of them that I'm using, Helvetica Bold in 44 and 36 point. Set up my colors that I'm using, same setup as before, with slightly different pin names, and same setup here. And then let's get to the different part here. So my text, I set up a couple of text objects here just with sort of some dummy text. Then when the program actually runs, it creates this date string object that's equal to a string. Oh, sorry, someone just told me we can't see the code view. Thank you for that, I appreciate it. So I'll back up a bit. You can just see here I'm importing a bunch of libraries. I'm setting up my display. I'm setting up my fonts. Setting this up over SPI. Create a couple of text objects. And then the bulk of it here is in this while true loop. We do this. The date underscore string variable is the result of creating a string from the input. So that input in parentheses will actually hang out there. The code when this runs will just hang out there waiting for a serial input to come in. It could be from the REPL. In this case, it's coming over from my computer running Python. When it gets that input, we then split it into two variables, day and date. And that's done with this split. And we choose the character that we split on, which is that slash. That could be a pipe. That could be other characters that are not going to appear in your time. Then I change the text in my two display.io objects, the text area and the text2 area, to be day and date. And those already have their setups up above for where they appear on screen and what font they use. We refresh the display, and then we sleep for an hour. So if I rerun this, so what I'll do is I'll just hit save here, and you should see my, oh, actually that won't do it. Let me open the file on the microcontroller itself. That's not it. There we go. So when I hit save here, my terminal program is already running. So this is waiting right now, the hour or so. My e-ink display and Itsy Bitsy, they're kind of stuck in this waiting mode. It happens to already say Tuesday, but it's kind of stuck in this waiting mode, waiting for some serial input. So what I'll do is end and relaunch that Python program. So now it's going to send the string, which means my Itsy Bitsy should receive that now, and it should refresh. So let's see. Are you going to refresh? Or are you just going to make a liar out of me? Maybe it'll refresh. I might get stuck here. Something else we can do, actually. Let's see, do we have time? No, you know what, I'll end it there. This one you have to take on faith. It actually refreshes it with each day. So yesterday it said Monday. And let's see, what else? So let me jump back to the product page to remind you, there's where you want to go to check this out. This is product ID 4197, and you can always type in the product ID in any of the search fields on the Adafruit site to get to a product. So if we know this one's 4197, type that into search, and there it will show up. And you can see this is the one with the nice big discount on it. So let me check in with the chat. Let's see, Mike Weaver says he's going to hook it up to RFID to see card info. That's really cool. I like that idea. And let's check in on the Discord. Yes, thank you. Todd asked, where was my code screen? I was not showing it. Sorry. And I will also mention, whoops, didn't mean to do that. I was trying to close the, I clicked on the Google thing. I was trying to close the little extra thing at the bottom. I just lost my train of thought. What was I talking about? Who knows? But there's the product. If you click on the Learn Guide page link, which is down below in here, you'll see we have info for using this in both Arduino and in CircuitPython, and CircuitPython as well as Python using Blinka on your computer. This will tell you everything you need to know about going and grabbing the driver for this and some sample code. This guide is actually both the tricolor and the monochrome. It's almost the same code with just some slight differences. And we have a lot of guides on e-ink. So if you check out this quick start from Anne Barella, that'll show you some things about throwing bitmaps on there. We have a name badge sample code. We have info about how to create your graphics, such as dithering. Let's see, Scotty asks, any inks with board same size or smaller than the display itself? The Featherwing is pretty small. If you look at, let's see, is that one linked in here? E-ink Featherwing. Let me go to the product page, actually. E-ink Feather. Okay, so this one, this Feather Friend is a little breakout where it's just the bare, it's not on a board, it just uses a little extension, which is kind of cool. The E-ink Featherwing here has a pretty minimal board. The PCB only pokes up for those mounting holes. And these are usually, you can usually separate these off of the screen with a little bit of heat, like a hot air gun on a low temperature might get it out, or some Goo Gone maybe. It's just got an adhesive backing on there. But you might want to look at that Feather Friend as a way to do that with just the bare display. We also have a flexible display that you can use with that. So, good question. Let's see, anything else? I think that's it. Yeah, Todd mentions we have a custom fonts learn guide, which is great. You can take pretty much any font, turn it into a BDF font, or there's another format, what's it called, PCF? I forget. But the bitmap, the BDF format is great. It just represents one typeface in one size, which is what a font is, and whichever set of glyphs you want. So you can have a minimal set or lots of them if you have memory to spare. All right, I think that's gonna do it for today. So there it is. There's our beautiful e-ink display with my new little very minimal computer here. But that's gonna be my hey, what day is today thing. So I shouldn't be screwing that up so much anymore. I'm gonna leave that on. So let's wrap this up, shall we? Okay, we shall. That's my product pick of the week. This is the monochrome 2.13 inch e-ink display Breakout. And I forgot to give that something to hook to my little board with. So we'll pretend we're gonna set this on there like a little shelf. There we go. It's sort of there. All right, that'll do it for today. Thank you all so much. This for Adafruit Industries has been me, John Park, in JP's product pick of the week. Bye-bye.